I want to go through some of the ways that you might have attacked number 4 from the other day. In your videos, you guys gave me a lot of different ways of attacking the equations, and I enjoyed watching those. I just wanted to make sure that we're on the right track for all the different problems that you have for number 4. So I'm going to go ahead and start with A, even though that you included that in your video. The one thing I wanted to point on this was to make sure we don't make a common error that I see on problems like this. On this one, that was the one where you took 4 times the absolute value of 8x minus 2, and that was equal to 8. On a problem like this, probably the most common mistake I see is people will try to distribute the 4, but I don't want to do that in this instance because the absolute value changes things a little bit. It's not like parentheses. So the 4 does not have the absolute value, so I can't include that with the values that are looking at the absolute value. So instead of distributing that 4, the best way to get rid of it was to divide by 4. And most of you did that with your explanations. From there, just a reminder, we have 2 different situations that could occur. Whatever's inside the absolute value has to equal 2. So that value could equal a positive 2, or it could have been a negative 2. Well, that value was the expression 8x minus 2. So we're going to look at these 2 situations, the one where 8x minus 2 is equal to 2, and another one where 8x minus 2 is equal to negative 2. So when you solve these 2, you find out that x was equal to a half, or another situation would be when x is equal to 0. And a lot of times you're going to find that out where we're looking at the absolute value. There's going to be 2 different situations that we have. Now that won't happen all the time, but there are a number of these where we'll have 2 solutions. All right, on part B, this time they threw a square root at us. Whenever you see that square root, really your goal is, how can I get that square root isolated? So that's my goal, is to get that square root of 4x minus 8 by itself. Well, I can do that in a couple steps. One of them is I can subtract 9. And then I can divide by 3. Now I have the square root by itself, and the reason I did that is I can get rid of that square root by squaring it. So on this one, we end up with the value of x equals 3. Now, it's probably good practice to just double check and make sure 3 is actually going to work. And the reason I say that is with square roots, we know sometimes we have values that'll give me a negative underneath that square root. So I want to make sure that this 3 doesn't end up doing that. So if I plug 3 in, I'd have 4 times 3, or 12, minus 8, and that gives me a positive 4. So I'm in good shape. I'm okay as far as the square root is concerned. But it is good practice to always check it and make sure it's actually going to work. All right, this next problem, x minus 3 squared minus 2 is equal to negative 5. Probably a lot of you looked at this one and said, okay, x minus 3 squared. Well, that is x squared minus 6x plus 9. And then you see the x squared and the x, you know you need to get it equal to 0. So if I were to do that, I had 7 already. When I add the 5, I now have 12. And so x squared minus 6x plus 12, I'm going to try to factor that if I could, which would mean I have to multiply to get 12 and add to get negative 6. And I start trying some different factors. 12 and 1, well, that's not going to work. 6 and 2 is not going to work. 4 and 3 is not going to work. So it turns out I can't factor this one, which would mean my next option would be quadratic formula. So if I did the opposite of b, that's going to give me a positive 6. If I do b squared, that'll be 36 minus, and then 4 times a would be 4. times c would be 48. And that's all over 2a. Or in other words, I have this, 6 plus or minus the square root of negative 12 over 2. Well, we got a red flag here. We've got that square root of negative 12. So that tells me I have no solution for this one. So if you tacked it that way, that's fine. But we actually could have gotten there a little bit faster, or a lot faster actually. So what I like to do on a problem like this, as soon as I see I have a quantity that's being squared, instead of actually multiplying it out, I'm going to try to get it by itself. So I'm going to get that x minus 3 squared by itself by adding 2 to the other side. Well, notice what we end up with here. I've got the quantity of x minus 3 squared that has to equal a negative 3. Well, the reason I would get that squared by itself is I try to square root both sides, but I'm going to run into that same problem I had a second ago where I'm trying to take the square root of a negative value. And so that again leads me to the no solution. Another way to think about it is I'm taking that quantity and I'm squaring it, which means it has to be positive, but they want it to equal that negative 3. So I know that can't happen. Okay, so don't always jump into multiplying it out. Sometimes it may be better to try to isolate it and then see, okay, can I save myself some work? All right, this next problem. Probably the conventional way, the way that most of you attacked this one was, again, to multiply it out and see what happens. So let's do that. Let's say I multiplied out the left-hand side. I multiplied out the 2y minus 3 times y minus 2. So if I did that, I'm going to have 2y squared. I'm going to have negative 3 and negative 4, so negative 7y plus 6. Over here, I've got negative 12y plus 18. Again, I've got the y squareds, I got the y, so I'm going to try to get it equal to 0. So I've got 2y squared. If I add 12y to the other side, I now have positive 5y. If I subtract 18, I now have negative 12. All right, so now I'm going to try to factor it. So maybe generic rectangles would be helpful. So I got 2y squared and negative 12, which means I need to multiply to get negative 24y squared and add to get 5y. And I can get that by using 8 and negative 3. So factored here, 2y squared and 8y both have 2y. I didn't give myself much room, but I got y there. 2y times 4 would give me 8y, and y times negative 3 would give me negative 3y. And negative 3 times 4 gives me negative 12, so it works out. So factored wise, this is going to be 2y minus 3 and y plus 4. So my two answers here would be y equals 3 over 2, or 3 halves, and y would equal negative 4. So nothing wrong with that. You can multiply that out, see what your values are, and then factor to get your final solution. Here's maybe a different way you can think about this one. And maybe you like this, maybe you don't. I've got that 2y minus 3 times the y minus 2. If I look at that second side, though, or the right-hand side, I might notice the 12 and the 18. They both can be divided by 6. So I'm actually even going to pull out a negative 6 out of those two terms. So if I pull a negative 6 out, I have now 2y minus 3. All right, well, you might say, okay, wait a second. I got 2y minus 3 on the left side and on the right side. So I'm actually going to move those all together. So I've got 2y minus 3 times y minus 2. And now this negative 6, I'm going to bring it over and make it plus 6. And then the 2y minus 3. So now that equals 0. All right, well, if you think of these as two terms, this is one term, this is a second term. Well, those two terms have a 2y minus 3 in common. So I'm going to pull out the 2y minus 3. If I pull it out of the first one, I'm left with y minus 2. If I pull it out of the second one, I'm left with positive 6. And notice what we're left with. 2y minus 3 times y plus 4, which was the same thing we got when we factored it. And so we get the same solution. So maybe not a conventional way of attacking it, but just another way to think about that one that may or may not be a little bit faster. All right, part E, the dreaded fractions here. Well, we talked about if we don't like fractions, let's get rid of them. So a good way to do that is look for a common denominator. In this case, our common denominator would be 3x. And we're going to multiply everything by 3x. So I'm going to multiply each term by 3x. All right, so if I do that, I can cancel the x's here, and I got 15. 3x over 3x is 1. 1 times 1 is 1. Over here, the 3's will simplify, and I'm left with 4x squared. So we got a lot simpler equation now. All right, so on this one, maybe I go ahead and divide by 4. I go ahead and do the square root. I just have to remember when I do that square root, we actually have two situations. We have either a positive or we have a negative 2. So you have to make sure that you took care of both of those situations. Another way you could have done that when you got to here, maybe you said, okay, with the x squared, I want to get it equal to 0. So if you subtracted 16, and then you notice both of those have a 4 in common. Then I look at x squared minus 4, and I think about, okay, how could I maybe factor that? Well, that's a difference of squares, where I have x minus 2 and x plus 2. And we get the same two solutions. X equals positive 2, x equals negative 2. Now 4 could never equal 0, so that doesn't factor into our solution. All right, part F. We see that absolute value. So in the back of our mind, we're probably thinking, all right, I got two situations. But before we start jumping out to break steps, look at what they're asking you to do. They want you to find some value here where we take the absolute value of it and end up with a negative 6. Well, we know no matter what that value is inside of the absolute value, once I do the absolute value, it can't be negative. So I don't even have to do any work here. There's no solution for that. Okay, so don't just jump into your steps. Always look at it and ask yourself, what do they want me to find here? And in this case, we don't have anything that works. All right, another one with fractions. This might be another one where you say, okay, 15 and 5, let's just multiply everything by 15. And that would be a good strategy. That would be fine. I'm going to show you an alternate way that you might attack it, which, again, maybe you like this, maybe you don't. If I looked at this, I might say, okay, I've got two fractions. Is there any way I can get those two to have the common denominator? Well, in this case, our common denominator would be 15. So what I'm going to do is I'm going to make this have a denominator of 15. And I can do that by multiplying by 3. So that means this is 18w minus 3. Now, I'm not messing with the 3w for a second. Over here, I've got this fraction. All right. Well, now that I have common denominators, what I'm going to do is I'm going to take this fraction to the other side. So I'm going to do that by subtracting. So I'm going to subtract 18w minus 3 over 15. So let's see what we have now. We've got negative 3w on the left side. Over here on the right side, I've got 12w minus 18w, so negative 6w. I've got negative 16 minus a negative 3, so that's like adding, so we got negative 13. and that's over 15. Now all I have to do is get rid of the fraction. I can do that by multiplying by 15. And I'll go from there. So 15 times -3 is -45W. So I'm going to add 6, so that gives me -39W. And -13 over 39 would be my value for W. So I'm going to end up with a positive, and in this case, it's going to be a positive 1/3. All right, so just a different way maybe of attacking it. If you went through originally and did this, you said, okay, 15 is the common denominator, so I'm going to multiply that by 15, that by 15, and that by 15. That would have been fine as well, okay? Either way would have been in good shape there. All right, then the last one. This is another one of those where I asked you to explain those on the video. And a lot of you on this one multiplied things out. It was already equal to 0, so you tried to factor it and went from there. Nothing wrong with that. I'm going to show you, again, kind of an alternate way maybe of thinking about this one. When I look at this one, I notice, okay, it's got an x plus 2 that's being squared. And then I have a 4 that's multiplied by the x plus 2. So I briefly mentioned this one day, but what I'm going to use is what's called u substitution. I'm going to say, okay, since they both have x squareds, I'm going to call, or not x squareds, but x plus 2s. I'm going to call u x plus 2. So my new equation, instead of x plus 2 squared, is now just u squared. Instead of 4 times x plus 2, I've got 4u, and then minus 5. So this one's not bad to factor because I can multiply to get -5, I can add to get 4. So in this case, I would use u plus 5 and u minus 1. So my two solutions right now are u equals -5 and u equals 1. But I wasn't searching for u, I was searching for x. So I'm going to go back to this equation. Well, one of the situations was u is -5, so I need x plus 2 to equal -5. So x equals -7 is one solution. The other situation, I needed u to be 1, so x plus 2 has to equal 1. So when I subtract 2, x is equal to -1. Just an alternate way of finding those two values. Multiplying it out, doing it the way a lot of you did on the video, that was fun. So as we approach these different equations, you're going to find different strategies that work for you. As long as they're algebraically sound, I don't care which way you go with it. As long as you show me your steps, I'm okay with you trying different ways to attack these equations. But I was just giving you some ideas that might work for those different